Projectile Motion by Ryan D. Brawl. In our experiment, we demonstrated the concept of projectile motions. We rolled a ball down an incline, along a ruler, and off a table. We can determine the acceleration of the ball through the equation A equals 0.7 times g times the sine of A, where A is the angle of the incline and g is the gravitational constant. We can determine the horizontal velocity by using the equation Vx equals 2 times the square root of A times s, where s is the length of the yellow ruler. We can determine the distance the ball will travel once it falls using the equation D equals Vx times h, where h is the vertical height from the table to the floor. We can determine the ball's time in flight before hitting the ground by using the equation T equals square root of 2 times h divided by g. We know these equations work, but we don't know why they work. So let's take a step back and learn a few concepts about projectile motion. What is a projectile? A projectile is any object with a velocity that moves along a flight path due to its mass. An object dropped from rest is a projectile. An object thrown straight up is a projectile. An object thrown at an angle is a projectile. Moving in 2 dimensions. A projectile that moves in 2 dimensions has 2 components, horizontal and vertical. Horizontal movement. If we ignore air resistance, the horizontal movement of a projectile can be described with this equation. Velocity equals displacement over time. Velocity is the speed of an object traveling in a certain direction. Vertical movement. The vertical movement of a projectile is determined by gravity. The Earth's gravity causes objects to fall at a rate of 9.81 meters per second every second. That's about 32 feet per second every second. The moon is much smaller than the Earth, so it has much less gravity. The same object on the moon would fall at a rate of 1.6 meters per second every second, or about 5 feet per second every second. What is trajectory? When you combine a projectile's horizontal and vertical movement, you have its trajectory. The path that a projectile follows is known as its trajectory. What is a parabola? A projectile tends to follow a trajectory known as a parabolic curve. The shape of a parabola depends on the initial speed and the release angle, but all projectiles launched at an angle follow this parabolic curve. What is a parabola? Continued. You can see examples of parabolas in your daily life, including sports, like when a baseball player hits a ball, video games, like when a soldier throws a grenade, architectures, such as the Arc here in St. Louis. How do I calculate projectile motion? In order to calculate projectile motion, you need to know some things about the projectile first. Wait, let's slow down a little bit. Let's take a simpler approach. So how do I calculate projectile motion? Let's start by making some assumptions about the popular game Angry Birds. First, the Angry Bird, when flung, will move at a constant velocity. That's v equals d over t that we learned earlier. The velocity of a flung Angry Bird is 10 meters per second, or about 33 feet every second. It will travel 33 feet for every second it's in air. The Angry Bird is on Earth, which means it's pulled by gravity that pulls objects down at the gravitational constant of 9.81 meters per second every second. The Angry Bird is launched at 3 different angles, 30 degrees, 45 degrees, and 60 degrees. Knowing all this, we can calculate the Angry Bird's projectile motion using formulas devised by Italian physicist Galileo Galilei over 400 years ago. In our first test, the Angry Bird is flung at 10 meters per second at an angle of 30 degrees and flew for 1.02 seconds, traveling a total of 8.83 meters. We can see these calculations by plugging in what we know. First, we get the horizontal velocity, Vx, and the horizontal velocity is 8.66. Then we get the vertical velocity, Vy. The vertical velocity is 5. We can calculate the time of flight with these variables and plugging in 9.81 for the gravitational constant. That means that the Angry Bird will be in flight for 1.02 seconds. And the distance traveled by plugging in all the variables that we've calculated is 8.83 meters. Now let's take a look at another test. The Angry Bird is flung at 10 meters per second at an angle of 45 degrees and flew for 1.442 seconds, traveling a total of 10.2 meters. Once again, we can plug in the formula and get 7.07. Plug in the formula for vertical velocity and get 7.07. We can calculate the time of flight, and we can calculate the distance traveled, which is 10.2 meters. Finally, our third test, the Angry Bird is flung at an angle of 60 degrees and stays in the air for 1.766 seconds and travels 8.83 meters. We can calculate its horizontal velocity to be 5, its vertical velocity to be 8.66, its time on flight is 1.766 seconds, and the distance traveled is 8.83 meters. Now some explanations. Why does a projectile follow a curved path? An object follows a parabola because of how the two separate components of motion, horizontal and vertical, are affected by gravity. The horizontal component is not affected by gravity at all, and so it changes in a constant and linear fashion. However, the vertical part is affected by gravity, and so it will increase in height, then decrease, accelerating due to gravity. This is why it goes up, hangs for a moment, and then comes down in a parabolic arc. Explanations continued. Why is 45 degrees the optimal angle for projectiles? Well, it's a bit complicated, but basically, the distance traveled by a projectile can be calculated with this formula. Sine of 2 times the angle times v squared divided by the gravitational constant. The important part is that strange zero-looking symbol is the plugged-in angle. It's been determined that the sine function reaches its maximum output of 1 with an input angle of 90 degrees. The longest range a projectile can travel is expressed by the formula 2 times angle equals 90 degrees, which means half of that is 45 degrees. So, long story short, a projectile, in other words, travels the furthest when it's launched at 45 degrees. Conclusion. In our experiment, we demonstrated the concepts of projectile motion. A ball was rolled down an incline, along a ruler, and off a table. We've learned that gravity affects its vertical motion, but does not affect its horizontal motion. We've learned that we can calculate an object's velocity by measuring the distance it travels over a span of time. We've learned that we can measure the distance it will travel before hitting the ground. However, the ball does not land in the same exact spot every time. So are our calculations wrong? Was Galileo not as smart as we think he is? Yes and no. The formulas we use to make these calculations are known as kinematics. Kinematics is a subfield of physics that describes the motion of objects without considering the forces that cause them to move. These formulas do not consider things like air resistance or drag, the speed at which you release an object or the angle at which you release it, the spin of that object, the shape of that object, the composition of that object, particulates in the air. There are many factors in physics to account for. In fact, it would be impossible to account for all of them. We can only hope to get as close as possible. So there's a lot more left to learn. But for now, let's just play some more Angry Birds, shall we?